These are the bolded problems for chapters 5.1 and 5.2, day 1. The first problem in chapter 5.1 asks us to find the relationship between 64 and 12 and to make sure that it's in lowest terms. So again, I'm paying attention to order. 64 is first, so it is the numerator. 12 is the denominator. To put these into lowest terms, the bottom, they're both even, so that would be, I can divide them both by 2. So that's the same as saying 32 to 6. And I can divide both of these by 2 as well. So that would be 16 to 3. For the next one, they're asking us to compare 2.5 to 3.5. The 2.5 comes first, so that's the same as 2.5 to 3.5. So I can say 2 times 2 is 4 plus 1 is 5, so that's 5 halves. 2 times 3 is 6 plus 1 is 7, so that's 7 halves. That's the same as 5 halves times 2/7, because I'm going to multiply by the reciprocal. That's the same as 10 over 14, or if I had canceled early, the same as 5 over 7. So the relationship between 2.5 to 3.5 is the same as the relationship between 5 and 7. The last one for this chapter is 1 2/10 to 10. So here I have, the first number is 1.2, 1 2/10. The second number is 10. I need to make this a whole number. To do that, I'm going to bump it up by multiplying it by 10. What I do to the top, I have to do to the bottom. So that's the same as 12 to 100. I can divide both of these by 2, and that would be 6 to 50. I can still go down one more step by 2. That would be the same as 3 to 25. So the relationship between 1.2 and 10 is the same as the relationship between 3 and 25. All right, let's look at chapter 5.2. With this, we're talking about applications again, just like we were in the examples. The first problem, and these are rate problems, and your goal in the end is to get the number on the bottom down to 1. They're asking you to look at a car takes 3 hours to travel 252 kilometers. That should be km. And they're asking you to look at the relationship of the rate of kilometers per hour. And what I like to do with these is figure out what they want, what am I looking for, and set it up that way. So I'm looking for kilometers to hours, kilometers per hour. Remember that line like that? We can read that as per. So here we have kilometers is 252 and hours is 3. So what I need to do to get this to be something over 1 is to divide this into this. And 252 divided by 3, let me try some short division. 3 goes into 25 8 times with 1 left over. 3 goes into 12, 4. So that would be 84. I did it. I'm pretty impressed. 84 to 1 for number 3. Or we would really read that as 84 miles per hour. Again, sometimes you see that P for per. It just sort of depends on how we're reporting the data. In number 13, we're interested in the price of orange juice. So they're telling me that a 6-ounce can of orange juice costs 96 cents. And I want the unit price in cents per ounce. So cents, C for cents, per, O for ounce. So I'm going to set this up. Now remember, in our other problems, like over here, it was 64 to 12. So I set it up, the first number was the denominator, the second number was the numerator. And that works really well if all you're dealing with is numbers. But if you're looking at a real-life application, we care about what we're looking for. And I'll explain this later, a little bit about independent and dependent variables. But for now, let's just worry about if they want it cents per ounce, set it up that way. 96 cents for 6 ounces. And again, to figure out what the price per ounce is, I'm going to divide 96 by 6. 6 goes into 9 once, with 3 left over. 6 goes into 36 6 times. So that's the same as 16 cents per ounce. 6 ounces for 96 cents, 1 ounce for 16 cents. So here's another problem that gives us applications that you might actually, see in your real life. Here they're telling us that a truck's odometer reads 15,208 miles and 208 3/10 miles at the beginning of the trip, and 15,336.7 miles at the end of the trip. And they are telling us that we use 13.8 gallons. So let's see. First of all, I have to find what the difference is between these two numbers. And in the interest of time and space, I'm going to use the calculator that you can't see. I know I'm cheating, but I'm the teacher. I'm the video star, so. Okay, so the difference in these two numbers, the miles traveled, net is 128 4/10 miles, divided by, or compared to, 13.8 gallons. And again, I'm going to use my calculator because I'm the boss, and I'm going to divide that by 3.8, and I get 9.3 miles to the gallon. Not very good mileage, but it is a big truck, I guess. And that's not a decimal point. So those are the bolded problems for Unit 4, Day 1, and we'll see you next time.